Hello, pre-calculus students, calculus students, and all seekers of general truths. Let us continue our work here with annuities by studying the case where Jack is going to invest his money over a period of 5 years. And you can see here that the calculations can become quite tedious. Okay, so let me just explain how this would work out, right? So 5 years, that would be 5 years, that would be 20 quarters, right? And so we're going to have a total of 20 terms. Okay, so if you look at the previous problem, that was 1 year, so that's 4 quarters. And we had 4 terms, 500 times 1 plus 0.06 over 4 to the third, then the same thing to the second, and to the first, then to the 0th power. All right. So in order to solve this problem, let's try to abstract some of the variables here. And let me show you what I mean. So let's start out. The general pattern here is that we're going to have 500 and 1 plus 0.06 over 4. That's just 1.015. Right? And instead of to the third power, it's going to be to the 19th power because we're doing this over 20 quarters. Then the next one is just going to be 500, 1 plus, I'm sorry, not plus, 015, okay, to the 18th, okay, and then 500, 1.015 to the 17th, okay, and eventually we're going to follow that pattern until we get down to the very end, which is just going to be 500. Right, so, and we can think of this as well as 500 times 1.015 to the 0th power. So there are a total of 20 terms, 20 quarters here. And you can see that to add all of this up would be insanely tedious, right? And if we were to go even further, maybe 30 years, that's some investments, some annuities actually last that long, 30 years and some of them go monthly, so 30 years monthly would be 360 terms. So that would be insanely complicated and tedious, all right? So we're going to approach this problem in a slightly different way. And I'm going to make up a few new variables here. So I'm going to call this entire expression here sigma. This is the Greek letter sigma. It means sum, or it means to add it all up. Okay, so sigma is equal to all of that mess. All right. Now, I'm going to perform a little bit of algebra here. So I'm going to create a second equation, and I'm going to call this 1.015 multiplied by sigma. Okay. So that's like taking 1.015 and just multiplying by every single term here. So the first term that I have is going to be 500 times 1.015 to the 20th power because I'm multiplying this term by 1.015. The second term is going to be 500 times 1.015 to the 19th power. You can kind of see the pattern here, 500 times 1.015 to the 18th power. Plus plus 500 times 1.015 to the first power. Okay, and I know this seems very odd as to why I would do this, but the reasons will become a little bit more clear in just a moment. Just understand that this is how we get, if we take 1.015 and multiply by the whole thing, then this is what we would get. Okay. Now, next step, I'm going to take the top equation, which is sigma, and I'm going to subtract the second equation. Okay. And let's watch what happens. If we subtract it on the left-hand side, this is what we get. If we take it on the right-hand side and we subtract it, what we get is 500 1.015 to the 19th minus 500 1.015 to the 19th. So you see that every equation, or sorry, every term in the top equation has a partner on the second equation. So that's going to cancel, and this is going to cancel. And we can kind of keep on going, right? So to the 18th power, that's going to cancel, and this is going to cancel, right? So the what I highlighted in yellow, and the 17th power, there's a 17th power in this dot, dot, dot. And even this 1 right here, there's also a 500 to the 1 power, 500 times 1.015 to the 1 power in this like this ellipse, this dot, dot, dot right here. So every single term on the top and second line is going to cancel out except for 2. There are only 2 terms that will remain. So this is going to be gone, that's going to be gone, this is going to be gone, this is going to be gone. And what are the terms that are left over? Well, it's this one, 500 times 1.015 to the 0. And remember, we're subtracting, so subtract 500 times 1.015 to the 20th. Okay. All right, now our goal here is actually to solve for sigma, right? We want to know how much money Jack is going to have in 5 years. And we've got it boiled down to a pretty nice looking equation here. So I'm going to do 2 things. First, on the left side, we're going to factor out a sigma. So that will leave me with 1 minus 1.015. And on the right side, I'm going to factor out a 500. And that will leave me with 1 because 1.015 to the 0th is just 1 minus 1.015 to the 20th power. Okay. Then one more step here, or a couple more steps rather. Sigma is equal to 500, 1 minus 1.015 to the 20th, divided by 1 minus 1.015. Okay? And so this is what our original equation, sigma, the sum that we were aiming for, this is what it's actually equal to. And now we can put this information into our calculator. And our grand total is $11,561.83. Okay. So if we were to take all these original terms here in this first line and just add them all up, this is the number that we're going to get. So this is called the I think it's called the telescoping series. That's the technical name. You don't actually have to know that at this point, but we use this idea in order to figure out the sum of a complicated but a complicated sum that has a clear pattern to go along with it. And you can see here as a quick check that if he had no investment, right? If Jack just saved $500 for 5 years for 20 quarters, so $500 per quarter for 20 quarters, this would be this would be exactly $10,000. Okay, so this is very reasonable that if he uses this annuity plan, he actually gets a little bit more money, in this case $11,561.83. Okay, so this is how we can kind of compare the 2 investments and see if it makes sense to invest. All right. All right, so we're going to end this video here, and again, we'll continue this lesson. We're going to abstract these ideas out to just some variables. All right? As always, thank you for watching, and have a wonderful day.